Hello students, today we are going to see about 5th unit, the end of your syllabus. First topic in this, you have text search algorithms. So till now we have seen what is retrieval system, how it is going to store the document, how you are going to do the indexing, and how you are going to create a pattern for retrieval system. Here we are mainly focusing on the text search algorithms. So we have 3 classifiers in the text search algorithms. So first one is full text scanner, word inversion, multi-attribute retrieval. So we have different types of classical text retrieval techniques in the database. Like we have to work only on the textual database because I am talking more over about the text. And we have to identify the relevant items and we have to eliminate the items which are not satisfying your search. For example, I am checking a word called cat. Okay. So if I have catch, okay, so catch is not, actually when you search you will get the cat and catch, but these two are not relevant, right? So cat is an animal, catch is some action word, okay. So this can be done using your full text or word inversion or multivariate, multi-attribute retrieval. So this is your intro for your text search algorithm. And in addition to this text search, we can also use some indexing mechanisms where you can index each and every word which are frequently found. Okay, for example, I am using more, the I am searching more. So I can add into your dictionary called where you are using frequently these words. And you can also I'll keep all these frequently used words in one document, okay. Then whenever they are asking, I'll directly link this particular to the database, and first the search option will be provided in this thing. So this is the meaning of this one, and you can also give some additional search mechanisms. And the basic intro or whatever the basic concept for text scan system is, you have to be accessed to text through the query terms. So if I take my Google server engine, or if I write here hybrid is a word I am going to search because it is based on the text search. So this hybrid will be your query. So I'll convert this into some query like in order to search the word called hybrid, and the H may be small or capital, that is later, but this have to be done in the form of the query terms. So when all of the text, okay, the query will be linked to some database. So if this particular word have been scanned over the complete database, what we can use, we can get the relevant items which are related to your query. So this is a process where we are going to use a text search only using your queries. Query will be some word. So if you see the architecture, so you'll have the database, so complete database of your data, and this is text streaming architecture. From the database, you will have the term detector, whatever the term you want to take. And here you will have the query resolver and user interface. Suppose the user enters any query, it will check the query resolver. Query resolver will check for the term detector, and detector will directly access to your database where it can get the exact relevant words which are available in your database. So this particular database contains the full text of items. Okay, so the term detector is a special hardware software that contains all the terms which are searched in the previous system or some system where you have some logic between the items, like you may have AND logic or logic like that. And it will also take the input and detect the existence of the search term. If the search term is available, it will directly resolve, send to the query resolver and get the items, and it can be detected and to go for the final logical processing. And query resolver does 2 functions. So what are those functions? So it will accept the search statement. So first function is it should accept the search statement, and second it have to check these particular search terms to the detector, and it's also accept the results from the detector, and it has to give to the query satisfied for the search item, and it should add the weight. So first one, accept the query, add the weight. Okay, for the term it have to add the weight, whether why we will go add the weight, whether it is relevant or not, to check the relevancy, right? Okay, so it will also pass the information to the user interface, because the resolver plays an important role because it acts as an interface between your database and your user. Okay, he will be the main person who is going to pass the information between the two sides. Okay, so and also it should check whether it is satisfying the items which are requested by the user or not. So the worst case search pattern, the magnitude of the searching the character will be O of n. Okay, because it is checking whether n character is at least n minus m plus 1, that is magnitude of O of n. Okay, and the comparison will be O of n into m, because if you have n symbols and m characters, you have to check each and every symbol according to the each and every character. So they are trying to give more improvements using n plus 1, because n star m is highly complicated when compared to the n plus 1. So this research is going on in order to reduce the complexity. Okay, so in case of the hardware search algorithms, so you'll have the hardware search machines where you'll have the parallel search machine. So the example for here is, I have the query resolver. In the worst case, I have only one query resolver. What I'll do is, instead of one, I'll create one parallel or distributed system. Whenever I get a word, that word will be distributed over all the systems, and wherever the relevant output is coming, you will give to this particular thing. So this will help in order to reduce the complexity, because this part will search, this part will be searched, this part will be searched. You are searching parallelly. Okay, so this can be done using the hardware search mechanism by keeping multiple nodes for the given system resolver. So in the software system, you can you can use the multiple detectors execute at the same time. So there are two types of data streams approaches have to be sent. In the first approach, what you are doing, you are checking the complete database. In the second approach, you are going for the random retrieved items. Okay, so what you will do, suppose you have the complete database over here. I got a query word. So what I'll do, I'll search the complete database. But in case of the second approach, I'll pick the random database items where I will predict that my query is available. Okay, so this is the second one. So how you are going to do this? In this, I want to predict means I should have some index values, right? So according to the index, according to the relevancy, and according to the weight of that particular term. So this can be done. So if it is not satisfied, again I have to change the search logic, or I can change the logic completely, or I can add some additional search logic for that particular query. So what are the different examples of this one? So index searches, first one searching for the stop words. What I'll do, I'll keep all the stop words in one index, so that whenever I'll get a stop word, I'll remove this particular thing. Okay, and can directly link the is there, here he is there, here she is there, or if, all these are stop words, so you can easily identify. Second one is search for exact matches when stemming is found. Stemming we have seen, right? If you have connect, so connect will be stemmed with the connected, connecting. Okay, all. So what is the stemming word? This for connect. So connect will be indexes to all these words. Search for the terms, both. You don't want to use those both leading and trailing. Exactly, I want to only use the connect word. Searching for the symbols that are interword symbols. Example, you can put comma or you can put hyphen. So all these types of index things will be indexed separately, so that we can easily directly go to that particular thing. Now, the full text search function does not require any, whatever we discussed was about the second one, that is randomly, right? So it does not require any additional requirements. What it will do, it will directly scan the complete database without any indexing part, because I don't want anything. I'll directly go to that particular database. I will search and I'll get the thing done. Okay. So in an index system, we have to remember what are the basic indexes have to be done, and how they have to be determined, and how many hits have been done, and how many flaws you got it. Next, the streaming also provides a very accurate estimate of the current search. What we are doing in the streaming, I am searching each and every line. So there is no scope or there is no chance of missing any item or any term in the database. Okay, but the thing here is it is very difficult to locate the possible index when you are going for that particular search in the dictionary also. So many of the hardware and software algorithms use the finite state. So already you have learnt automata. What we will do in the automata? So just what you will say, briefing that one. So you will have finite automata. So 0, 1, this is my final state, this is start state, Q1, Q2 and this is Q3. So whenever I will get this particular 0, 1, this is your automata, right? So what are the different components you will have? I is your input system. So whenever I'll get a query, so for every word, what I'll do is I'll create automata. What I'm doing here, T, H, one more you should have. So this is final state, right? So this is your input. So A state, B state and C state and D state. Okay. So I is your input symbol, right? So whatever input I'm giving, that is your input symbol. So what are the other terminologies you'll have? S is a set of possible states, P is a set of productions and special called initial state, final state. So simple. So what are the S? All the states. Suppose if I have Q1, Q2, Q3. If I take Q1 is your initial state. So this is your S0. If Q3 is final state, it is your SF. What is a production exactly? So if I draw the diagram for this, yeah, Q1, Q2, if you have Q3, so this is my start state. Remember always this double circle will implies your final state. So what is a production? Q1 on A moving to the Q2. So this is called as set of productions, right? So this is one production. For example, Q2 on B moving to Q3. So this is also production. Suppose if I have like this on C. So how I'll write Q1 on C is going to Q3. This is also the production. Okay. So this is your finite automata. So already you have learnt, you have the subject, just you remember. So this is a set of text search algorithms. We have more text search algorithms which we will refer in the coming sessions. Thank you.